Hey guys, today we're going to be starting chapter 6, and I think I told you at the start of this unit that this whole unit is super important for grade 10, so both chapters 5 and chapter 6. Chapter 5 is all about linear equations, which there will be like three different chapters on in grade 10. And now chapter 6 is all about polynomials, which there is only one chapter on in grade 10, but it is still an important one. So that's what this is all about. We're going to be learning about polynomials. Today we'll just kind of do an introduction, learn some of the terms and how to kind of work with polynomials, and then we'll start getting into adding and subtracting and multiplying and dividing polynomials later on. So let's get into it. So we're going to start again just by going over some terms that you need to know. So a polynomial is an algebraic expression that has numbers and terms, including both variables and possibly exponents. So for example, 3a squared plus 2a minus 4 is a polynomial. When we say terms, what we mean is the different parts of a polynomial that are separated by either plus signs or minus signs. So for example, 3a squared is a term, positive 2a is a term, negative 4 is a term. It is important that when we say this, you know that the symbol, so either the plus or minus sign that is separating the terms, actually goes with the term behind it. So this isn't just a 4 with a minus sign in front of it, the term is a negative 4. The variable is then the unknown. So we represent it with a letter. So in the case of this polynomial, a would be the variable. The coefficient is the big number in front of a variable. So for example, in the term 3a squared, 3 is a coefficient. In this polynomial, positive 2 is also a coefficient because it's also in front of an a. The constant is the number that doesn't have a variable with it. So this should say the constant is negative 4 because again, the sign goes with whatever's behind it. So the constant is negative 4. And then the degree of a term is whatever the exponent is. So in the polynomial that we've been using as an example, in the first term, the degree is 2, since the a is squared. In the second term, the 2a, the degree is actually 1 because everything can always be written with a little imaginary 1 for an exponent. And then the negative 4, because it doesn't have a variable, it will have a degree of 0. If a term has two different variables, you add their degrees together. So for example, if we looked at this polynomial here, again, the a is squared, so that term has a degree of 2. The 3a, that a doesn't have an exponent, so it's an imaginary 1. And then for the next one, 3ab, since each of those exponents would have, each of those variables would have an imaginary 1 for an exponent, it actually has a degree of 2. And then the degree of the entire polynomial is just the degree of the highest term. So again, if we look at this polynomial here, the a squared is the highest degree with its degree of 2. Therefore, the degree of the polynomial is 2. And then just a little reminder about area. It is the amount of space a shape covers. Usually, if you are representing area as a polynomial, it will have a degree of 2, since if you think of like the area of, say, a square, it's length times width, or a rectangle is length times width. It has two different variables, the length and the width. Each of those would have an imaginary 1 for an exponent, and so the degree of that would be 2. Perimeter, we can also represent with a polynomial. So it would be like perimeter is 2 times the length plus 2 times the width. Since each of those terms each of those terms only has one variable, so it would have a degree of 1. And yeah, essentially, polynomials can represent a bunch of different scenarios, including money, perimeter, area. But a perimeter cannot include a fraction where the variable is on the bottom, so the denominator. So that's really the only thing that can't be a polynomial. And we'll come back to adding and subtracting in a different lesson, so we won't worry about that for now. Another thing that you're going to have to be able to do with polynomials is to model them, or essentially draw something to represent that polynomial. We do this by using different colors to represent positive and negative. So positive numbers will be one color, negative will be another color. There will be a legend that tells you the difference between those on like a test or quiz. And then you just use different sizes and shapes to represent different terms. So constants are always really tiny squares. Something with just one variable will be a small rectangle, so a single x or a single y will just be a small rectangle. Variables with a degree of 2, so like an x squared or y squared, will be a large square. And then anything with 2 variables, like an x and a y in the same term, will be a large rectangle. Again, there's usually on a test or quiz, well, definitely on a test or quiz, there will be a legend that tells you that. In your textbook, if you forget or have any questions, just let me know. So the number of each tile is then reflected by the coefficient. So example, if you had 4x squared, x squares are large square tiles. Because it's 4x squared, you would have 4 of them. If the constant is 6, you will have 6 small square tiles. If you have the same size tile for both colors, so both the positive and negative, they will cancel each other out. That is called the 0 rule. So for example, if you have an x tile and a negative x tile, they will cancel out. If you have like positive 3 little squares, so positive 3 constants, and negative 4 little squares, 3 of those will cancel out and you will be left with just negative 1. When you write a polynomial, you should write it from largest to smallest degree. So for example, x squared, then x, then your constant. If you have 2 things that are the same degree, usually an x squared would go before an xy. And then when you gather like terms and simplify, you either draw or write the same terms together. In order to simplify a drawing, you just cancel out those opposite terms. So that's your 0 rule that you would use. If you're writing them, then you just add or subtract your like terms together. And equivalent polynomials, that's just another term you need to know. Essentially, it just means that an unsimplified or the original polynomial is equivalent to the simplified version. Okay, so let's look at some examples of all of these things that I'm talking about. Okay, so the first example that we will look at is 5x squared minus 3xy plus 4x minus 6. So if we were to look at this, we have 1, 2, 3, 4 terms. The degree of the entire polynomial would be 2, since that is our highest degree. So that is the degree of the whole polynomial. Our constant is right here, so it would be -6. We have 2 different variables. We have both y and x variables. We have 3 different coefficients, which are the numbers in front of a variable. So that would be 5, -3, and 4. And then the degree of each one of these terms, this would have a degree of 2, also a degree of 2, is 1 plus 1, a degree of 1, and then a degree of 0 for our constant. The next thing I want to go over is just how to kind of rearrange different polynomials. So if this was a polynomial, it's just not written from highest to lowest degree. So we actually want our x squared at the front, then our 2x, then our constant at the back. When we move a term, we take the sign that's in front of it and move it as well. So this would end up as, actually I'm gonna get rid of this just to make this more obvious. So 5 plus 2x minus 6x squared. When I move the 6x squared to the front, I do have to take the minus sign with it. This entire term, including the sign in front of it, moves to the front. Then I'm going to write my positive 2x next. And then to move the constant to the back, because I got rid of the negative sign, this is now a positive 5. So I do have to write the plus in front of the 5. So this is what it would look like when it's rearranged properly. And the next thing I want to talk about is how to evaluate a polynomial. So if you were given, let's say, example 3, 2x squared plus 3x minus 4, and then you were told x equals 5. All you need to do is take that 5 and plug it in anywhere that you see an x. So this would become 2 times 5 squared plus 3 times 5 minus 4. And then you just have to solve by using BEDMAS. So don't forget exponents happen before multiplication. So this would be 2 times 25 plus 3 times 5 minus 4. And then 2 times 25 is, of course, 50 plus 15 minus 4 would be 65 minus 4, 61 would be your final answer. Okay, so when it comes to modeling polynomials, this is an example of a modeled polynomial. You never have to draw a model of a polynomial. That is never going to be a requirement on a test quiz or the PAT. However, you do need to know how to read a model of a polynomial. So what this means is obviously the big square is our x, is our x squared, which means that in this case, the white ones are positive, the black ones are your negative ones. Each one of these skinny rectangles must be an x. The black skinny rectangle, even though it's sideways, doesn't matter which way it's turned, but because it's black, it is a negative, and then these little squares are our constants, and they must also be negative. So the first thing that we need to do is simplify this, which means cancel out our opposite like terms. So we have a negative x. We also have 3 positive x's, so one of those will get canceled out. So that's step 1, is to simplify by canceling opposite like terms. And then we just write whatever is left over. So we have 1 x squared. It's up to you if you want to put the 1 in front of it. We have 2 positive x's, so we write plus 2 x's. And then we have 1, 2, 3 of the negative constants, so that is negative 3. And that would be the polynomial that is modeled. Okay? If you don't like canceling out like this, you could have also written it right away without canceling it out as x squared plus 3x, because there's 1, 2, 3 of our positive x's, and then minus 1x for this guy, and then our minus 3, and then we just do our simplifying, where with our like terms, which are, in this case, our two x's, we can actually add or subtract those together. So we keep our x squared at the front. It doesn't have any like terms. There's no other x squareds. And then 3x minus 1x is just positive 2x, and then our only constant at the end. So you would still get the same answer. In that case, you're still starting by simplifying, and you just do that by either adding or subtracting your like terms. And we'll talk more about gathering like terms and simplifying them in the next lesson. Okay, so that's all for today.